We will continue our introduction to hypothesis testing by considering how to test hypotheses using confidence intervals. Notice that the same four-step process that we already used for constructing confidence intervals will also be used for conducting a hypothesis test. So those four steps are prepare, check, calculate with a sketch, and conclude. So to illustrate the hypothesis testing process very briefly, we're going to use an example from your reading assignment. I've reproduced guided practice 5.22 on the screen. I'll just go ahead and have you read through that briefly, and then we'll move on to discuss how that will be used for a hypothesis test. All right, so hopefully you paused the video and read through that. Now we want to go ahead and set up appropriate hypotheses to evaluate whether college-educated adults are better than random guessing on that question. So we begin by taking a look at the following. The words better than random guessing imply that we are interested in a proportion of college-educated adults. Therefore, our hypothesis will be that the population proportion is equal to a 1 out of 3 chance of guessing the answer correctly. Again, that's a skeptical position because it is basically saying that the chance is no better than random guessing on that particular question. The alternative would be that the population proportion differs from 1 out of 3. In other words, the proportion of adults that answer correctly differs from random guessing. At this point, I should point out one thing that you need to know. I have shown these parenthetical comments for each symbolic representation of the hypotheses. You're not required to put those down when you write your work on paper. You only need to put the symbolic representation of the null and alternative hypotheses. I'm adding the parenthetical comments for learning purposes, so you understand what those statements mean. So now that we've gone ahead and constructed a null and alternative hypothesis for this particular hypothesis test process, the next step would be to go get a random sample of college-educated adults. So suppose that we did that. We took a random sample of 228 college-educated adults, and the data we gathered showed that 34 of them selected the correct answer to the question. Notice that that's only 14.9%. So we're already a little bit suspicious of how well college-educated adults do with that low a value, because 1 out of 3 would be 33 1/3%. So in proceeding with the hypothesis test using confidence intervals, for step 2, we have to see whether we can model the sample proportion using a normal distribution and construct a confidence interval. That means checking 2 conditions: the independence condition, which in this case is immediately met because we took a random sample, and secondly, seeing if the number of successes, which in this case was 34, that selected the correct answer, and then the number of failures, which would be 228 minus 34, which is a large number, it's 194 people. We need to check whether those values are both greater than or equal to 10, and we easily see that they are. Therefore, the success-failure condition is also met, and we can affirmatively answer this question about modeling the sample proportion using a normal distribution, and therefore we can proceed to the next step in constructing our confidence interval. Now, if you've been keeping track of what we've done so far, you'll realize that we just completed the prepare and check steps for constructing a confidence interval in performing this hypothesis test. Here on the screen, you can see the work that I've done in its entirety for the calculate step. I've shown the construction of the confidence interval with a sketch. Notice that 14.9% is at the center of the interval. Have a p-hat and z-axis. I've shown the calculation of the standard error, which was used to scale the p-hat axis. I've shown the value for z asterisk, which corresponds to our confidence level of 95%. That means that 5% of the area was in the tails, and half of that area is in the upper tail, and I use that to find the z asterisk value with our guru. And then lastly, I use those 2 values to find the margin of error, which then was used to identify the endpoints on the left and on the right on the sketch. Okay, so that's the calculate step with all those steps, all those pieces of it shown on the screen. And what I would expect if you were showing work for a confidence interval calculate step. Okay, now we go to the conclude step. So the first part is evaluating the null hypothesis. We either have to reject or fail to reject it. Now in this case, because the null hypothesis value of 1/3, that is approximately 333 thousandths, is not in the confidence interval. So let's go back and look at that. Notice the confidence interval. I'm circling my mouse on the right-hand side. 333 thousandths would be very far to the right off the scale, well above the confidence interval that we constructed. Therefore, a population proportion of 1/3 is implausible, and we reject the null hypothesis in this case. That is, the data provides statistically significant evidence that the actual proportion of college-educated adults who get the Children in 2100 question correct is different from random guessing. In fact, we can say more than that. Because the entire 95% confidence interval is below 333 thousandths, we can conclude that college-educated adults do worse than random guessing on this question. And that concludes the overview of the hypothesis testing process. Now, I want to close by just highlighting that there are two possible decision errors that could be made. A type 1 error is when we reject the null hypothesis, which we did in the example that I just showed you, but an error could have been made in rejecting that hypothesis when in fact it turns out to be true. That's called a type 1 error. A type 2 error is failing to reject the null hypothesis when in fact the alternative is true. All right, that concludes this presentation.